yeah, it is important that we load ships properly, but human error does also play a huge part in it. And one potential solution, just like human car drivers, would be to have uh, unmanned marine vehicle. And this is a research field that is being pursued a lot, even in KAIST. In that paper, I read uh, how these sudden maneuvers or over use of rudder maneuvers can be reduced if instead of having a human driver, if we have a computer running the ship. So that could be maybe a radical departure from the current state of how ships are run. But I think just like how human error is the huge reason why we have a lot of car accidents. Similarly, if we remove the human out of the ship running process, we can reduce those kind of error. But yeah, it is important that we also include some kind of check to make sure that ships are not overloaded. I would be happy to hear more ideas about this.
So, so, so usually rollover or capsizing happens when water like gets into the hull of the ship, right, and decreases the buoyancy. So coming to the in the ship design stage, the, the appendages and methods we just discussed above, isn't there also one way? Can you hear me?
Yes, then is there any ideas in inspection stage?
Yeah, so I think maybe another one is, as Arif earlier suggested, using inflatable airbags. So when an emergency happens or some instability happens, those airbags will which are put like in different places strategically will just open and increase the buoyancy, artificially increase the buoyancy of the ship and filling up the void spaces in the ship where water can collect and capsize the ship. So in doing so, maybe the ship can't step on water line.
Regarding the inspection stage before launching the ship, I guess one way could be to use model ships in water. I forgot what it's called, like, where they test the ships before they make it into actual scale size ship. But I guess even with that, those kind of smaller ship, it will be impossible to uh, over stress or overload because, like for example, if we have our model ship made out of steel, and also if we have the real ship made out of steel, since the model ship is smaller, like it will be much more rigid, much more stronger than the bigger one. So it will be difficult to have an apple to apple comparison. So yeah, I guess for those this kind of inspection, the best we can do is computer simulation. Uh, by using computer simulators, we can overload the simulated chip and then inspect what happens. I think this is something that that they're already doing in the nuclear industry. They're using simulation to overstress a nuclear power plant to check what kind of problems can uh, can the engineers encounter. So I think again, simulation of computers could help with that.
I think that for prevent the rollover accident, it is the best is not to overload the ship for the ship owners, but it is but if this overload problem cannot be prevented, I think the good way is designing the ship by increase the safety factor for rollover and loading weight is can be another solution for this problem.
As you mentioned, rollover accident, sorry, rollover accident mostly occurs because of human factor, but the fact is human factor cannot be prevented. So as Adib mentioned, like human is more computer is coming the ship or that kind of part is maybe only the solution. So I think evacuating in emergency situation is more important. So rescue ships must come quickly, and the ship to keep the ship from sinking before rescue ship comes. So one of the idea to not sinking is that balloon ideas, as we mentioned in proposal presentation, to balloon the balloon and keep floating.
Can you also use maybe autonomous, like include, because I think the seawall ship accident, it's if I'm not sure, but was kind of partly contributed to the captain's errors. Maybe if we can introduce autonomy, we can like reduce the human errors that are contributing to the accidents. So maybe that's also we can try that.
I agree with that idea because I heard that the safety factor of airplane is about below about 1.5 or 7 things because the human error cannot make that significant accident, but the nuclear power plant has a safety factor about about 10 I heard 10 8 10 8 to 10 because the human error can make a huge disaster. So for the ship, we need to set the safety factor between the airplane and the nuclear power plant in between in the some value between that.
Oh, yes. Is there any other idea? Then that's it for today's discussion. Thank you for the informative discussion.
Thank you.
Thank you.
Thank you very much. I liked your live discussion, good discussion today. So I see many discussion topics and I'm happy to see that. I have a small, because we don't have enough time to continue my lecture. Instead, I have several comments on this. First thing is, Woo-sang, can you stop your sharing the screen? Right, thank you. We need to differentiate between static stability and dynamic stability. It was in the slide of previous lecture. Right here, let me show you. But it was not well explained there at the time. Right. So the first line here, the stable, in the parentheses they are saying statically stable. That means there is another one is dynamically stable. Right? So you should differentiate, as an engineer, you should differentiate between static stability and dynamic stability. So let me explain using this one, right? So I guess this truck is moving, right? Even looks like it's unstable, but it is moving on the road, I guess, at left-hand corner. But if you imagine that this truck is stay not moving, stay still. So we can say static stability, it is okay. When the truck stops, they stay there with this inclined position, but still stay there, not collapse, not turn over, right? But in the right-hand side, the other truck is turnover because probably the driver was in higher speed and probably turns a little bit with a higher angle. So if the driver was more careful, then the accident will not be happen. So in that case, dynamic stability also important here, right? So you should think about the two different stabilities, static stability and dynamic stability. But they are combined together. As you see from the truck case, the left-hand upside truck looks unstable, but statically it's okay, but barely okay. The margin is very small. That's why you can, if you turn quickly or speed higher, then it will collapse, turnover easily. So there is a small marginal stability there, right? So you need to differentiate between two. And then,
Professor, I had a
question. Go ahead. Yes, please. Question.
I yeah. So my question is the upper left truck, is that dynamically stable?
Dynamics with, so there is no exact criteria to say whether this is stable or not stable. You need to have a regulation. Regulation says if some magnitude is higher than this value, they can say this is safe, right? So there should be a marginal values which covers some disturbances. So it's not easy from seeing this only pictures, but it looks like an unstable car, right? But I'm saying that you need to careful about differentiating between two options for static stability and dynamic stability.
Thank you.
All right. Usually, so that as we have discussed in the regulation, something like a SOLAS is important. Let me show you this. So as you pointed out in here, for the ship design stage, you need to follow the international regulation on safety. That is SOLAS, SOLAS. So that all the requirement is written there. So as a designer, you need to follow their regulations or calculations. Well, one small, not small, but differentiation going to this slide is that these equipment or method, bilge keel, anti-rolling tank, is stabilizing fin. It is helping for when ship is running, not stop, not in the case of ship is not moving. So static stability is applies when ship is not moving. So static stability requirement should say that when ship is not moving, the ship should be stay there. But sometimes the disturbance is coming, something like a wind or wave, so that there should be some marginal values to there. So that GM, we will see in the next slide, my lecture, there is a requirement of a scale for stability values. But anyway, this bilge keel, anti-rolling tank, and stabilizer pin is more trying to applies to dynamic stability, or can say motion of the ship, rather than static stability. Bear in mind, and then we will continue next Thursday on more values on stability. All right. And I have another topic I want to discuss with buoyancy, right? Buoyancy, or like this one. Okay. So maybe, probably, this one is maybe better, right? So how many of you? Let me stop sharing my screen. Okay. How many of you can swimming? Say 10 meters of swimming. No? 2, okay, 3, okay. My question is your body. If you moving into the deep sea ocean, is your body going afloat or going down to the bottom? What is your expectation? Your body, without any device, any clothes, only your bare skin body. When
Float.
you,
Float.
so 2 options, right? Floating or down, back, submerged into the bottom of the sea, right? Can you turn on your cameras, Adib and Bereket? Adib, can you? All right. So 2 options, floating or sea bottom, down, fall down. So floating, raise your hand if you agree with the floating. 1, 2. And down to the bottom. 1, 2. What is your Bereket? What is your option? Turn on your mic.
I have no idea. Maybe floating. Yeah.
Floating. All right.
Yeah.
That is very tough question. That's why I'm asking, right? Tough question. Swimming, Olympic game, swimming, right? The swimming players, they float. and going very fast, right? As a ship, looks like a ship, right? But some divers, skin divers, they go down to the bottom, right? So I'm saying the static buoyancy of your body, nothing happening, no motion, no motion. What is the answer? If you have a chance to learn how to swim as a student, swimming student, you may have several courses of learning how to swim, right? One of them is in Korean is a 세우등뜨기. That is, you make your body as a ball and then stay in the water. Can you remember? Did you have that chance? But anyway, the answer is our body is very neutral to the specific weight, about one. And then if you have your breast is full of air, then your body is floating. If you don't have any air in your chest, no air, then your body is going down very slowly, because our body is almost the same specific weight as the water, around 1. So that if you have a chest full of air, it is floating, but it's a very small portion is floating. But it is something like an iceberg, right? Most of part is under the water surface, but still it is floating, barely floating, right? Barely floating. Something like if you have a Coca-Cola can or Coca-Cola bottle into the water, is very similar to your body. Small portion of the bottle is floating above the water, but mostly under the water, but does not go down. Right? That is the answer. So it's very complicated situation. So that when person is drowning, you can drown into the water and then dead person. After 1 hour, 2 hours, dead person, right? Then we may expect that the dead body is going over the water or down to the water base, seabed. It is still complicated situation, depending on what kind of wear you're wearing some your skin, depending on that situation, or also inside your body. There is a after death, say after 1 week and 1 month, some small chemical process or biological process is going on inside body. So that changes your specific weight. So that also dead body is also very complicated situation. So it's not easy. That's right. So it's interesting, right? Lastly, I will show you one more image that let me show you. Oh, no, this one. Where is it? This one. Lollipop, you can say. So that they are very stable one, right? So some people are trying to design a ship with this kind of a high value of stability, something like Lollipop. So the ship never capsize. When there is a big disturbance, they return back to the upright position like this Lollipop. So that is one idea. And then this one, recent accident in the Suez Canal. The ship is hitting the side of the canal. Why? Probably because of the high wind. And then we are saying this is also a kind of a dynamic stability of course keeping stability. The ship was want to drive straight in the middle of the water, canal water, but because of the disturbances coming from as a wind, I assume that. And then the course keeping stability was not small. It was small, not enough, so that the course was changed to hit the bank of the canal. So it's complicated. So once again, you need to differentiate between static stability and dynamic stability. And also there are different motions. Course keeping can be another dynamic stability. All right, that's it. Any more questions? No. Then we'll see on Thursday. Good. Bye now.